In our last lesson, we worked with perpendicular lines. We did some constructions. Today we move on into lesson 2, where we work with parallel lines. We'll start first with the definition, remind ourselves of what that is. And then we'll work at proving two lines are parallel by looking at pairs of angles formed by a transversal. So let's take a look. If you remember, this was the definition we've been using for a while of parallel lines. Two lines are parallel if and only if they lie in the same plane and do not intersect. Pretty straightforward definition. I think we've got that down already. In order to study parallel lines and determine whether they're parallel, we're going to use a third line. We call this a transversal. Trans would mean across, and verse to like go. So a transversal is a line that goes across two other lines. So in this picture we would have L1 and L2 are parallel, they look like it, and they are crossed by a transversal. We often name that transversal T for transversal. Now one thing that, we're going to look at pairs of angles formed by the parallel lines in the transversal. It will be angles like these two. We might look at these two, the one on the other side of it. We will look at this one and this one. We would look at this angle and that pair. There's also this angle with this angle way up here. This angle with this angle way down here. We've got a bunch of pairs. We could take that one and that one. I guess I did that already. One thing I don't want you to overgeneralize is this. A transversal is any line that crosses two other lines. The lines don't have to be parallel. That's still a transversal. Just that when we're working with parallel lines, well, our transversal will typically be crossing parallel lines is what I'm trying to say. Not very well. So what we want to do here is describe the location of each pair of colored angles below with respect to their relation to the parallel lines and the transversal. Okay, that's a mouthful. This first one, you look at the two red ones. How would you describe their location? Well, they're both below the transversal. They're not between the two lines. They're kind of on the same side of each line. Probably not really any other way we can describe them. These two, they're on the same side up here. They're both to the right of their parallel line. Okay, try to describe these pairs, this 2 and 8 and 3 and 5. Pause it a minute and see if you can describe those two. Hopefully you tried it. Well, unlike these in A, which were on the same side of the transversal, these are not on the same side. They're on alternate sides of the transversal. The other thing that's true is where this was to the left of the parallel line and this was to the left of the parallel line, they weren't between them and they weren't both outside of them. These two are interior. They're between the two lines that we're looking at. So they're on opposite sides or alternate sides of the transversal, and they're between. They're interior. Try this one. Okay, kind of similar here. What do you notice? Try to describe those for yourself. Okay, I've got them interior. They're both between the lines, like these two guys are, but they're not on alternate sides. These are on the same side of the transversal. All right, so with those descriptions, I'm going to give you 3 labels and see if you can figure out which one goes with which. So pause it. Try to match up those labels up there with the particular pictures A, B, and C. Okay, hopefully you gave that a try. Looked at the names. So we have corresponding angles. We have interior angles on the same side of the transversal, and we have alternate interior angles. Which one do you think goes with which? The suspense is killing me. Whoa. Boom. Did you have that? Corresponding angles. We'll look at that a little more closely in a minute. And then alternate interior. Yes, they alternate sides of the transversal, but they are interior. They're between these 2 lines we're talking about. And that leaves interior angles on the same side of the transversal. They're both above in this case. Let's take a look at this set first. Corresponding angles. What makes them corresponding? Well, if I were to take the right-hand side and drag it over, it corresponds. It sits in the same location, meaning it's left of the line and it's below the transversal. So it corresponds. So you can see that again. It's in like the same general spot. It's in a corresponding location, so corresponding angles. Here, these are interior angles. They're both between the lines, but they're on the same side of the transversal. And here's the third pair, alternate interior. Again, they're interior. They're inside. They're between the 2 lines, but they're on alternate sides of the transversal. So we have alternate interior angles. Okay, so why did I do that? What happened there? So they're their alternate interior, as opposed to, ooh, what did they turn into when I did that? Now they're not on alternating sides, and they're not interior either. You recognize those as corresponding angles now? They're both to the right of their line, and they're above the transversal. Everything in the rest of this lesson hinges on Theorem 17. The fact that if corresponding angles are equal, the lines are parallel. So Theorem 17, equal corresponding angles mean that lines are parallel. Pretty cool proof. Doesn't take much. Maybe from the picture you can tell that it's an indirect proof. Indirect proof. So let's walk this one through. We're given that lines L1 and L2, we just have those lines, and they have a transversal T, and we know that 1 and 2 are equal. We need to say, how do we know that? How can we prove that? So look what we've done here. Got an idea? Indirectly, if we're trying to prove that they are parallel, suppose what? With that hint, pause and see if you can work this one out for yourself. So are you back then? Well, suppose they're not parallel. So if they're not parallel, meaning they never intersect, then they must intersect. So what we're doing here is we're drawing a line that does intersect. Can you see the contradiction right away? He's suggesting you probably can. Thinking about our last chapter, what kind of angle is angle 2? 2 triangles CAB. You are right if you thought or said exterior angle, and what do you know is true about the exterior angle compared to the remote interior angles? Right. Let's take a look at this proof. So suppose they are not parallel. Then they must intersect because they're in the same plane. If they intersect in a point C up here, then they form triangle ABC. But angle 2 is an exterior angle, and therefore it's greater than angle 1, because an exterior angle is greater than a remote interior angle. But that's a contradiction, because we were given at the beginning that angles 1 and 2 were equal. Therefore, what we supposed that L1 is not parallel to L2, that they intersect. That's false, and the lines are parallel. This is huge because we're going to use this with the other pairs of angles coming up. So we've proven that if you have two lines that are crossed by a transversal and the corresponding angles are equal, the lines are parallel. We can use that now anytime we need to. Well, let's use it here with this corollary. Corollary says that equal alternate interior angles mean that lines are parallel. Well, how does this relate to Theorem 17? You will be proving this in the assignment, but think about just a minute. What are 6 and 8? If you said vertical angles, you're right. They have the same vertex and their sides are opposite rays. Well, what do you know about vertical angles? They're equal. So if 8 is equal to 6 and 2 is equal to 8, 2 and 6 are corresponding angles, right? So if 2 is 8 and 8 is 6, that means 2 is 6. And therefore, we know those two lines, L1 and L2, have to be parallel because they have equal corresponding angles. So here's how that one works out. If 3 is equal to 5, then the lines are parallel. Or if 2 is equal to 8, alternate interior angles would say the lines are parallel. Equal alternate interior angles mean that the lines are parallel. Next one, corollary 2. Supplementary interior angles on the same side of a transversal mean that lines are parallel. Interior angles. So if 2 plus 5 is 180, then those angles are supplementary, and it means the lines have to be parallel. Well, how is that related to Theorem 17? Think about that one a minute. So 2 plus 5 is 180. What else do we know here? Well, 5 and 6 are supplementary, right? And 2 and 5 and 2 are supplementary. So we had a theorem, didn't we? That supplements of the same angle are equal. And that would mean that 2 and 6 are equal. And there you see Theorem 17. Equal corresponding angle mean the lines are parallel. You'll be working on these in the problem sets coming up. There's another pair there, 3 and 8. Went past that a little fast. If those two are supplementary, then the lines are parallel. Could do the same thing. 3 and 8 are supplementary. 7 and 8 are supplementary. So 3 and 7 would be equal, and equal corresponding angles mean that the lines are parallel. Here's our last corollary. In a plane, two lines perpendicular to a third. So there's one, there's two. Two lines perpendicular to a third line are parallel. Well, hopefully you can quickly see why this has to be true. Perpendicular lines by definition form what? Yes, right angles. And this one also forms a right angle. Oh, and check it out. What position are they in? They are in the corresponding angles position. And equal corresponding angles mean lines are parallel. Why are they equal? Well, all right angles are equal. So we've got corollary 3 that says two lines, 1, 2, perpendicular to a third line are parallel. And it's obvious because they form right angles which are equal, so equal corresponding angles mean that lines are parallel. So here we go, practicing with these theorems and corollaries from lesson 2. And here are the proofs I just mentioned. So you're supposed to fill in statements and reasons. In this case, it's the statement that proves corollary 1. We just ran through it. If you want to back up and listen, maybe you can get some hints from that. Same with number 2, we're looking for the statements here. And corollary 3, same thing. All right, some folded paper. You can see it folded pretty neatly here. Looks like maybe they folded it in half first, and then they folded it in fourths again. An accordion shape. And we've got the edge is what we're looking at right now in the purple. So first question, what are B and C called with respects to AB, BC, and CD? So we'd be looking at this angle and this angle, B and C. What would you call them? And there are the lines we're talking about. And there are those two angles. What would you call them? Got several choices. Think it through. And if those two are equal, why are AB and CD parallel? Look back if you don't remember. What position are they in? And they're equal. If CD is perpendicular to DE, now it doesn't look that way in the picture, but they're saying if CD is perpendicular to DE, so up here, if that's a right angle, and DE is perpendicular to EF, and that's a right angle, so if those two are right angles, why is CD parallel to EF? Okay, so think about that. Maybe if I put this perpendicular symbol right here, it'll be a little bit easier to figure out. Okay, kind of messed that up a little bit. Let's move on. I did not know this until I saw it in this book. A sidewinder, they're called. It's a snake. When he travels, he doesn't leave a squiggly line in the sand, which is what I thought, or it would have been like a straight line through there. This is actually the pattern that he leaves. Kind of weird. So they've taken that, they've drawn a diagram of it here, and we've got T, the line of travel, which also happens to be a transversal here, and A, B, and C are parts of its track. So now some questions about that. What are angles 1 and 2 called with respect to the transversal? So angles 1 and 2, we're looking at an angle pair there. If 1 and 2 were each 60 degrees, what would you say about angles or lines A and B? Look through the theorems and corollaries today, and then tell why you would say that. 3 and 4, that's an angle pair. If one of them was 60 and one of them was 120, how are 3 and 4 related? Looking for a single word there. And then what would have to be true about lines B and C and 13Y? Pause before you move on when you got that, till you have that done. We're going into construction. Geometry is very present when you're constructing buildings. Here's what we call an I-beam. Obviously, the cross section looks like an I, and that's why we call it that. So we have lines A and B, and C would be the transversal. And we've got two angles labeled here, angle 1 and angle 2. Could you say that these two lines, A and B, were parallel if 1 and 2 were equal? Just realize what it says. 1 and 2 were equal. Don't necessarily go by the picture. How about if 1 and 2 were supplementary? Could you say they're parallel then? It's always a good idea to defend your answer. What if A was perpendicular to C and B was perpendicular to C? How about then? All right, here's another problem, and I always say it gets tricky when lines and triangles and stuff overlap, so I'll try to help you through this one. Some of the line segments appear to lie in parallel lines. Maybe you can see some of them might look like AE and BF, maybe DE and CE, maybe AD and CF, probably not L1 and L2. So that's the appearance. What can we prove? So you're supposed to trace this, mark the angles as needed, and then answer questions. Which lines are parallel if those two angles are equal? And then why? How about if those two angles are equal? Which lines are parallel? You saw there's a spoiler on the last one. Try to figure it out yourself. You'll need to have two lines and you'll need a transversal. So the trick is find the transversal. And how about if these two angles are supplementary? Which lines are parallel and why? If you've been in construction, you recognize this triangle. They have it as, architects would have it as a drafting triangle, but they also have them in construction to help create right angles, I should say, straight lines. As long as A, D, C, F are lined up, as long as they're collinear, they suggest that A, B, and E, F have to be parallel. And the question is why? Would those two always have to be parallel no matter what? And remember, important thing, identical drafting triangles. Another word there might be congruent triangles. They're exactly the same size and shape. So keep that in mind as you try to give the answer to 24. And why would BC have to be parallel to DE? All right, an optical illusion. Do those lines look parallel to you or not? To me, this looks wider over here than it is over here. I think one way you could tell that is if you take your book and you try to take a look and see from an angle like we did with that anamorphic art. So they're asking you to take just a part of it down below here. We have one of the V's. If 1 and 2 are equal, as I have marked there, can you say for a fact that X and Y are parallel? Then you have to explain why you say as you say. But what if we extended AB so it intersects line Y at point D? Anything change now? Well, with this given, maybe it does. If angle 1 is equal to angle 2, and BD is BC, BD is BC. Notice I jumped the gun there a little bit. Why am I able to say this angle BDC is equal to angle BCD? Well, remember what we just had here. BD is equal to BC. So maybe I can mark that here. Oh, come on, where are you? I don't know where it went. Oh, there it is. Okay, so we know that these two sides are equal. And we learned that if two sides of a triangle, BCD, are equal, the angles opposite them are equal. Does that give you enough to say that X and Y are parallel? In other words, is this true? That X is parallel to Y. So think that one through a little bit. Remember all the givens. We've got this. And now we just said BD is BC, and we marked a little bit more on the picture. So go at that one, see what you can come up with. So we've got two little short proofs trying to prove the same thing, that AB is DE in that picture right up above. I think if you pay close attention, you can get the right one at each. So the first one, it says that these angles here at B and D are right angles, that they're perpendicular, and that the two lines are parallel. You have to get answers down here for Y on 2 and 3. Same picture, the givens are a little different. Now we're saying that they're right angles. Can you prove that AB is parallel to DE? Two Y's to fill in. Next, we have a construction. A lot of points on this one, but you're supposed to follow the directions there. So I've got my 3 segments, And so I construct a triangle with them. Then I bisect the angle. And then I find some midpoints and we fill those in like that, and then answer some questions about it. About how many triangles, are they congruent, are sides equal, are all the triangles congruent? So several questions about this. And we get down to finally 37. Why is CG parallel to GD? No, that's not it. CG, that would be this one, parallel to DE, this one. Why would that be true? And then GD, that would be this one. You'll notice with parallel lines we use a little bit different symbols. So if I put two of them on, I know now that these two segments are parallel. And we want to know why. And then the last question is EG. Do we know this? Is EG parallel to AB down here? So think those through. Getting close to the end. Now we got some proofs here. Yay! We're trying to prove that AB, so AD, this one, is parallel to BC out here. It sure looks like it is. But we need to establish one of those, that theorem or the corollaries we had. So let's think this one through. We'll mark everything that's given. AE is ED. And angle E is equal to angle C, or BCE. How are we going to get those two lines parallel? Well, we also have to figure out which one would be the transversal. So if these two lines is what we're after, get them parallel, either this one is the transversal up here and forms some angles, or this one is a transversal. One of those two. And then we'd have to look at angle pairs having to do with them. There's a hint, because those sides of the triangle were equal, so maybe that'll give you enough to get there. All right. And then the next proof, we know this, and we know this. And we are trying to get AB up here, this one, AB parallel to CD. Now we've got a couple options for transversals. It could be this one, it could be this one, and it could be this one. If we're trying to get AB parallel to CD. So think that one through. Let's clear some of that out of there. So how can you get that? These two triangles right away, they make me think, oh, if I could get those congruent, maybe that would help me with some angles. So if I could get those two congruent, I might be in pretty good shape. And then there's a set 3. Feel free to work at that one if you want. So work these through. If you have any